All right. Uh, Good morning, everyone, and welcome to the second part of the lecture, today's lecture. It is my great pleasure to have as guest Philippe Morel. Philippe Morel is an architect, is a theorist, is the founder of EZCT Architecture and Design, and a co-founder of x03, which is a large-scale 3D printing corporation. He served as a founding CEO after initiating and creating the company. Currently is associate professor at the ENSA Paris-Malaquais, and he also teaches at Bartlett, and he has been teaching and lecturing all over the world for a very long time. And he has a long-lasting interest in the elaboration of the theory of computational architecture, which he has been developing again for several years now. And he also has been creating exhibitions, publications, and many other dissemination projects and events. So without further ado, I am going to leave the floor to Philippe, and I think his contribution to project and intention is extremely interesting and surely relevant. Again, thank you, Philippe, for doing this, for accepting my invitation, and the floor is yours.
Okay, thanks a lot. So you should now see my screen.
Yep.
Yes, everything is perfect.
Yes.
Okay, good. So first of all, thanks a lot. Sorry. Yes, thanks a lot, Alessio, for the invitation. It's really a pleasure for me to give this small lecture to your student in Bologna, in Italy. So I will present today some work I've done in the past, let's say, 15 years, almost 20 years. I was, I really asked myself, should I do a lecture about theory or a lecture about the work I've been doing? It's always difficult. I really wanted to give you a bit of more concrete elements about what I'm doing, and not just about let's say the theoretical discourse or hypothesis I'm developing. So yes, I will show you projects, or let's say design research. But before we start, I want to let's say present or introduce a couple of elements about why I'm doing this work for the last 20 years. And what are my interests in doing this. So if you know the recent history of architecture and industrial production, you obviously know that right after the Second World War, or more precisely, in fact, almost during the Second World War in the US, people started to develop what we call today CNC machines, so computer numerically controlled machines. And obviously here you see a CNC milling machine, one of the very first one invented or developed by Cincinnati, which it's a name of a city in the US, but it was also the name of a machine manufacturer. And these machines, the main, let's say what matters when we look at these machines, it's not only the shape of what it can do. Obviously, some people, like Greg Lynn, they worked about and they wrote about that, about the introduction of this kind of machines in the architectural production. Also, the French architect Bernard Cache did this as well. But what I'm interested in mostly when I look at this machine, it's not so much the shape of what it can produce, the new products, industrial products mainly, but mostly the conceptual and the mathematical difference. It's a difference in nature, the difference between the analog and the digital. Because at the very beginning, at the very heart of these machines, probably the most important element is obviously this difference, the fact that we are moving from an analog world to a digital one, and what does it mean for us as architects. This digital world, in fact, is not present only in these types of machine, but it's a computational revolution we are all embedded in. We are living in this computational revolution. It took a bit of time to come to, or let's say, to influence the architectural discipline. But one of the first domains where this computational revolution was extremely important was obviously in the banking industry and in the financial industry, as you can see here in the 80s. The computational revolution also today is very important on the large scale in what's called logistics. You cannot imagine getting your Amazon product delivered to your door without a fully computationalized or computerized supply chain. And this computerized supply chain is the science of logistics. If you look at that, if you look at this logistics, you see that it also has an influence on the way we build, not only on the way we build, but on the very nature of architecture. Traditionally, architecture is something with empty spaces, but when you look at most of the contemporary buildings, especially the one dedicated to logistics, in fact, emptiness does not exist anymore. Architecture is just a kind of packed accumulation of products and goods. And also, I think this new paradigm is very important because maybe obviously we don't build an house in such a way, but according to me, it's really changing the whole Western metaphysics of architecture, which traditionally, again, was more or less the kind of science of composition and also the science of the empty space. And I believe that architecture is also changing very dramatically based on those things. So what I'm interested in fact, it's not just about, let's say, the way we manufacture architecture thanks to new kinds of machines, but it's also, my feeling is that I'm interested in a kind of deeper revolution, which is a revolution of the digital, the revolution of the discrete, but also what happens, around us in the world. So, for example, if you look at knowledge, if you look at the way we learn, the way we communicate, if you look at those applications, for example, you see that we enter also a completely different domain, and the domain of applications. And I will show you at the end of this small lecture, I will show you a 4-minute video by my student in London who worked on application development. I think this also has a very deep influence on what we are doing. So if my thesis is that if we want to say something interesting in architecture, we should not over-focus on a tiny part of it, for example, manufacturing, fabrication, or even design, but we should try to embrace those things all together in a new conceptual discipline, because they are all deeply intricated and let's say related to each other, one to each other. The same for the issue of data. If you look at applications, for example, obviously these applications produce a lot of data. The amount of data which is produced every day is just like insane. But also, again, we are moving from an architecture which was based on a few general assumptions, sometimes, you know, coming from engineering, sometimes coming again from what we could call the science of design. I don't really know what is the science of design, by the way, but let's keep this word. But now we are moving from those traditional things toward an architecture which is data-based, which is based on big data. And again, this is also very much changing the way we design and the way we produce. For example, if you look at this, you know, it's a traditional image of a weather forecast where we try to visualize a hurricane here on the western coast of the US. Traditionally, you use like formulas coming from physics, and you apply this formula about mainly fluid dynamics. You apply those things, thanks to computers, to the weather forecasting discipline. But recently, some startups said, okay, probably we don't need this. We just need the data, you know, and maybe we can predict the weather just by looking at the cell phone signals, and maybe this will be as efficient as using the 200th century old style, old equations of fluid dynamics. You know, for example, the Navier-Stokes equations. And again, you know, this is very much changing the way we see science, because ultimately, if you can predict the weather forecast, it's very difficult, you know, to do prediction, to do weather forecasting. If we can do that just by looking at the cell phone signals, then what's about architecture? You know, should we need to use all knowledge we learn at school? Or maybe we can just look at the behavior and the habits of clients, you know, what they are doing online, what they are doing with their own application, and then maybe we can come up with a very interesting design, you know, answering the need of clients. So I think all of these things are absolutely radical evolutions. It has an influence on medicines. Obviously, it has again an influence on stock exchange, the way we trade at the stock exchange with a robot market, you know, with computers just analyzing patterns. And it also has an influence on the very way we deal with money. For example, we know that money, cryptocurrencies, for example, are now mined and generated by computers. And again, if we come back to the discipline of architecture, we have like big data taking the forms of images, for example, on Pinterest. And again, ultimately, you should ask yourself, okay, what's architecture nowadays? Is it just about Pinterest says it is, and if you look at that in a bit of a speculative look, you can see that, yeah, you try to, as students, you try to know what architecture is about by looking at Pinterest. Then you produce something which will ultimately end up online, probably also that will be Pinterested, or that will be pinned, let's say, etc., etc. And again, you change the discipline of architecture. So all of that, I try to give it a name in my discourse, in my work, both practical and theoretical work. And this name, I use the word computationalism. And according to me, computationalism is really, let's say, it's not just about using the computer in architecture. You know, I mean, honestly, at some point, I don't really care, you know. about what we can do with a computer in architecture. What I'm interested in is in this shift from rationalism to something else. Rationalism was born at the Renaissance, obviously in Italy, probably mainly during the Quattrocento, and ultimately, according to me, it's over. Rationalism is now being replaced by something else, where the human mind, where human intelligence is superseded by computational intelligence. And because of that, I say that we enter the age of computationalism, and computationalism is about the massive and radical introduction of computers in absolutely everything we are doing. So it's a very short introduction, but that's what basically I'm interested in. So now let's be a bit more focused. Let's go to my practice. When I was a student, the first software I was confronted to, obviously I was confronted to AutoCAD, ArchiCAD, and all these extremely stupid softwares. I mean, if I have to make a choice between different kind of stupid stuff, I would definitely choose AutoCAD. At least you can make precise drawings with AutoCAD, precise 2D drawings, but honestly, that's all it can do, except if you are an expert in Lisp. And if you are an expert in Lisp programming, at least you can also do some interesting things in AutoCAD. Yeah, the other kind of software like ArchiCAD and all of that. I mean, you can't even imagine producing any kind of interesting architecture with this. I have to say that, but I hope you know about it. But as a student, I discovered this. It was Rhino 1. I mean, this is not a screen capture of Rhino 1, but at that time it was Rhino 1. And all these tools, you know, in Rhino, you have all of these icons. And you say, oh my God, I mean, what's all about? How can I mean, how can I learn that? So first you're afraid of it, obviously, but then you start to get curious. So you learn more or less everything about it. And then you start to get even more curious and you want to go beyond, you know, beyond the interface. And you want to know, for example, what's a spline, what's a NURBS curve, what's a parametric surface, you know, and all of these things. And this is what I was really interested in again. And I said, okay, probably I cannot know much more about that by working with Rhino. Keep in mind that at that time, plugins like Grasshopper didn't exist. And by the way, you know, I knew very well a few years later in 2005 the birth of Grasshopper, because as a teacher in Paris, I invited David Rutten, the creator of Grasshopper, to give a lecture. And it was really funny because Grasshopper before Grasshopper was Rhino with 5 additional icons. It was called reconstructivism. It was a kind of intellectual project from David. It was a very interesting thing. And eventually it ended up in becoming Grasshopper, this kind of amazingly successful and smart tool. But I was interested in something else again, and I said, okay, let's move away from architectural software, from CAD software, and I discovered something called Mathematica. Mathematica, I love it because when you open a Mathematica page, there's just nothing. It's a blank page. So you don't have the risk of being influenced by preconceived architectural primitives or shapes or function or whatever. And what I love about it is that it's about computation. You know, it's really about technical computation, and it's not about architecture. And again, you know, I was, and I'm still is, obviously, I was really interested in the conceptual foundation of architecture, not just about new shapes, but a new definition of architecture. And I had the feeling that I should consider architecture as something about symbolic stuff, you know, manipulating symbolic things, and not just geometry, but any kind of symbolic entities. And also, what I was interested in was that I said, probably architecture, if we enter the world of deep computing, you know, deep computation, probably we cannot use a tool or any kind of software that does not, that has limits, let's say. I need something, maybe I'm not going to do quantum mechanics, obviously, with Mathematica, but at least I need something that would allow me to do quantum mechanics in architecture if I'm interested in. You know, I really wanted to have something without some sort of limits. Just imagine like a musician. Just imagine a composer. I'm sure that probably the most interesting composers in 20th century music, they were interested in expanding the domain of music, you know, not just about playing around with a few notes, but really expanding the domain of music, you know, by giving new definition of what music can be. Just think of John Cage. Just think of I don't know, like Luigi Nono in Italy, or some of these amazing composers. You know, it's not just about tools. It's again about concept. And this is why I very consciously chose Mathematica as my favorite platform. And as you can see here, if you want to do quantum physics, yes, you can do quantum physics, even if you are not obviously obliged to do something like that. So now let's, based on these preliminary things, let's jump to what I'm doing. So I started my practice in 2000, and obviously I've made a lot of things in these past 20 years. In 2004, I was invited with my colleagues to work on a set design. So it was a very basic project, but conceptually it was kind of interesting. It was for the famous non-standard architecture exhibition at the Centre Pompidou in end of 2003 and early 2004. I had to design this ribbon shape you see here. All of this shape, which was obviously produced with digital tools, but also the pattern on the floor. So the shape was done with an internal structure, and the pattern on the floor was printed with gigantic digital printer. In fact, this work was kind of foundational for me, because obviously I used Mathematica for that, but it was also about jumping into using mathematical tools to create space allocations. And so space allocation had some constraints, so it was really like constraint-based design, or design under constraints. It's up to you, you can call it the way you want. And each of these 12 zones, you know, 12 areas, were supposed to have the same surfaces, 45 square meters. And we use Mathematica, working in close collaboration with a mathematician at Paris University, Marie-Van Tessier. And you know, since then she remained my, let's say, second mother in architecture, because I learned a lot of things in mathematics thanks to her, and I keep learning those things today. So if you look at the ribbons, it was all created through programming, and again, we had to pay attention to the deformation of images so that we can reduce the deformation of images when they are printed on this white ribbon. So we had to pre-deform the image so that when they are printed in a deformed shape, they would look good. All of this was very interesting. And when it came to the pattern on the floor, we run some experiment with various different kind of patterns, and these different kind of patterns also were kind of both visually interesting in themselves, but also the resulting pattern was interested in terms of surface, because it has it's a pattern that was extracted from a three-dimensional surface, and it had some very interesting properties. So I browsed kind of quickly through that. We exhibited this in Japan in an exhibition in Tokyo. And also we presented a couple of projects that were even more ancient than that, but I don't present this today because it would be much too long otherwise. But this project here you see was also very interesting one. So basically you see the surface here. And you see the model was made on a very big milling machine in the Netherlands in 2004. It's a 2 by, I think it's almost a 2 by 3 meter model. So obviously, ultimately, this has some sort of beauty. But we were not really interested in this at the very beginning because, again, it's a kind of byproduct. This is a kind of byproduct of a project that was absolutely focused on producing a pattern, you know, for the floor. And this pattern had to cover 1,200 square meters at the Centre Pompidou in the South Gallery of the Centre Pompidou. But based on that, I kept being interested in the issue of pattern. So I kept working on that with Mathematica, and I started to be a bit more interested on the mathematical properties of surfaces. So I started experimenting with the analysis of different kind of properties, you know, like for example, curvature properties, flow lines. I mean, what we can do, you know, with the surface, because obviously for the Centre Pompidou, the pattern was a two-dimensional pattern. We didn't have much problem in manufacturing those things, you know. But when I told myself, okay, but just imagine, you know, and by the way, it was also the very own discourse of Frédéric Miguero, the main curator of this exhibition. He said, oh, wow, it would be so amazing if we would just have had like 300,000 euros for the set design. Can you imagine building this set design in a three-dimensional way, building this amazing three-dimensional floor at the Centre Pompidou? This would have been just amazing. And of course, I mean, this would have been amazing, but then we would have faced some deep manufacturing problems, you know. And I said, okay, what? Just imagine we would have to do that. We would have to build these things in 3 dimension. What would happen? So I really started to be more and more interested in the let's say both in the mathematical and physical properties of surfaces. So I kept working on that in a in something that would become architectural investigation with Mathematica. Uh, Eventually, this ended up being my architecture diploma. Uh, I graduated in 2004, so a few months later, a few months after the opening of this exhibition. And I developed this work, so the full title is Empiricism and Objectivity, Architectural Investigation with Mathematica. And I wanted in this book, I wanted to readdress the, let's say, the deep nature of architecture. And ultimately, I ended up saying that architecture is just about knowledge, and the, let's say, the shape that knowledge is taking in the discipline of architecture is pattern, you know, is a pattern. And I ended up saying that more or less knowledge equals pattern. And obviously, at some point, when we look, for example, at artificial intelligence, you know, ultimately, at that moment, I was not so aware of all these amazing advances in artificial intelligence. But right, I still believe that ultimately, the only way to express such or such a knowledge is by understanding its pattern, and also by the pattern of things, and by creating new ones. But basically, I looked at that in a very philosophical way, almost in a kind of Wittgensteinian way. I was also studying philosophy at the university at that time, philosophy of language, and also logics. And so and again, I wanted to know more about what was behind, you know, the software. So I started to code my own Bezier spline function and all of these things, Bezier curve, Bezier surfaces, looking at, for example, how you just build it in a recursive manner with such or such an algorithm, or just by using analytic, the classical or canonical analytic definition of Bezier. You know, those things are not complex, but let's say, you know, I was very frustrated as a student to use software I was not participating in. You know, it was, I had the feeling that I was not a person writing music, but that I was only a person that could use, or that can use predefined or yeah, let's say pre-composed pieces of music. You know, I was absolutely not happy with that. There's a big difference, obviously, in being a spectator when you watch a movie, and being the movie maker. You know, I really wanted to be the guy behind the camera, not the guy in the theater watching at the movie. You know. So I started also to write my own function for analyzing mathematical properties of surfaces, like different kind of curvature, Gaussian, I mean mean curvature, minimal and maximum curvature, Gaussian curvature, blah blah blah. You know, all of these things. I'm lucky enough that this work has finally been acquired by the Centre Pompidou for its, let's say, art book collection. And I kept working, you know, as you can see here, with different kind of things, analyzing visually and mathematically the properties of surfaces, you know, and finally ended up with some interesting pattern, self-adaptative pattern for the development of non-developable surfaces. So this was the kind of, let's say, practical output of this research. I defined what I believe. I mean, it was not so used at the time. I don't even know if it was used at all. But what's called an iso-Gaussian curvature pattern, which is self-adaptative and which gives you some extremely interesting way to approximate non-developable three-dimensional surfaces. So then I stopped being interested in this. I mean, stop is maybe not the word, but I wanted to experiment with some other kind of geometry. This was continuous and differential geometry. I wanted to go into something slightly different. Again, I was and I'm still interested in logics. I'm interested in discrete geometry much more than in continuous geometry. I'm a guy who is absolutely not really interested in geometry, in fact, let's say, which is a bit weird for an architect because, yeah, I mean, all architects are supposed to be interested in geometry. They are supposed to be interested in three-dimensional shape. I'm probably a kind of Alberti-like architect. I'm more interested in paintings than sculpture. I'm more interested in abstract things than material things. So, right, I'm a very classical architect, and again, I'm not a very materialist guy, which is weird because you will see later that I also made some experiment with materials. But yeah, I do it for the sake of architecture, let's say, you know, because these are things you cannot avoid, you know, in architecture. But deeply, conceptually, I'm interested in logics, algebra, two-dimensional things, abstract architecture. So my godfathers are more Alberti and Eisenman than some more materialist guys. So basically, I wanted to see, okay, if we can produce a bicycle frame like this, you know, by making use of genetic algorithm, what can we do for architecture? So genetic algorithms are quite easy things to code. Here is a very quick coding of genetic algorithm I made for my student in Mathematica to show how you can sort a random sequence of 0 and 1s, for example, and after a few hundreds of iteration, you can sort them out and have all of the 0 on the left, all of the 1s on the right. Things that would take an amazing amount of time if it was not about using genetic algorithms. So we worked on this project, which was a computational chair project. Why do we choose a chair? Okay, all architects want to do chairs. So it was a kind of a conscious choice, obviously, but it's not because I was interested in design. It was simply because it's cheap to produce a chair and I didn't have any money. It's a canonical object, so you can see what makes your own project different from the previous one. You know, it's a simple element. A chair is a chair. it's the same for the last 2,000 years, and it's gonna probably be the same for the next thousands of years as well. So you know, the fact that when you do a chair, I mean, the function of it doesn't change, allows you to focus on its nature, you know, on the deep conceptual nature of and let's say of its design method mainly. So here's a small movie. Tell me if the movie plays. Yes, perfect. So here you see the way genetic algorithms work. We started with a bunch of matter which was discretized in small voxels, and we run genetic algorithm making structural analysis so that ultimately you end up with the most efficient project. Then we kept working on that for a pavilion project, for the s03 pavilion competition in Paris. And rather than using mechanical constraint, we used natural light conditions. So here you also see how the project, let's say, design itself, just based on a few natural light constraint. So it's really it's pure form finding methodologies, obviously in both cases. But let's go back to the chair. So we ended up producing 25 of this chair. These are like, it's a scan of some of the notes I was taking at that time for the writing of a few algorithms. So again, just writing algorithms, contouring algorithms in itself, it's not so complex, but remember that I'm not a former mathematician or computer scientist, so I had to learn and to do it by myself. And also when you have controls within controls, within controls, within controls, it ended up being not such a trivial thing to do. But basically we ended with this thing, which was also presented later in a few exhibitions. So the s03 pavilion competition was based on the same principle, starting with a full block of matter, a kind of dumb and empty box. I mean, not so empty, by the way, because in fact it was full of material voxels. And then we ended with this, running some subdivision algorithms ultimately, and we kept it exactly like that, as it is. For the project, so here it's a plan. So it's kind of traditional architectural drawing. It was a very Greglin-like project in a sense. I think it was conceptually interesting, but I have a very ambiguous feeling with this project because it's at the same time quite beautiful. Yeah, I hope so. But I don't really like it, you know. So yeah, it's I would love to see this built, because I think it would be an amazing piece of architecture, very, very elegant, extremely romantic in a sense, but probably because it's a bit too romantic, I don't really like it. So, but this is a matter of taste at some point. Obviously, at that time, it would have been almost impossible to build this for a cheap price. But now we can do it with large-scale 3D printing machines, and you will see that later. So this is the model for this pavilion. And here a closer view of it. Based on this, you know, my work is very like iterative. You know, I try to build things on top of something which came before. So I asked myself, okay, this is nice for a chair, but what about scaling this up? You know, if we want to make a building based on that, I mean, how can we do it? We cannot just cut slices of wood. It doesn't make sense, you know. So I started to let's say I started to rework on this issue of voxel-based construction, coming up with also some conceptual housing scheme that I called the universal house. So this is simply an elevation of a universal house, and a universal house would be something that would be based on elemental and identical components, same voxels, being inspired, you know, by what happens in discrete computation in computer science, just by looking at things in terms of neighborhood. You know, never paying attention to the global geometry, but only paying attention to the relation that one element can have with the next one. So it's very much a kind of relational definition of construction. It's not based on any kind of metrics. You know, metrics doesn't matter because it's an element, so it can have any scale. You know, we never speak about meters, centimeters, measures or things like that. It's a pure discrete and digital architecture, and also a relational construction method, you know, because again, what you look at are your neighbors, exactly in the same way. I mean, in the way you do with cellular automata, for example, you look at neighborhood relationship. So we looked at the relationship between cellular automata like scenario, but also discrete geometry or digital geometry. So for example, here are the 24 digital planes. So a digital plane is the equivalent of a continuous plane, but then because it's discretized, you might have some constraints, so you cannot obtain a perfect plane. But you have different kind of planes. So I mean, I cannot go into the detail of this during this lecture. It would. I mean, it's a lecture in itself ultimately. But anyway, I designed this universal construction cube, which is a self-interlocking cube, which allows you to be plugged in any kind of direction, and in any direction you can always plug it, and it's always stiff. This is it. We used this later for a pavilion competition for Archilab in 2012, but here is a more explicit view of this universal cube. Also, this allows you to have a perfectly standardized cladding system for the panel, for the facade, for example, for insulation and all of these things. So this is a view of the universal house with a construction block next to it. It was published in I think it was in 2012 or 2013 in AD, in an issue of AD, curated by Georges Legendre, as an illustration of an essay called Sense and Sensibility. At the same time, at the office in 2010, end of 2009 and 2010, we bought a robot. I knew that we would never be able to compete with the big universities like ETH, you know, where some of my friends and colleagues are teaching, because they had a lot of money coming from the state, and they could buy big robots. So I said, okay, let's not try to compete in terms of hardware. Let's focus on software. So we bought a robot, and I hired a student of mine as an intern to develop a software which would eventually become HAL. So now it's a software you can buy. Thibaut has created a startup company with that. I don't know if it's a success, but I think it is relatively good, which is good. So basically, we initiated this development of HAL at the office, cutting different kind of things like foam, or doing foam cutting and other kind of stuff. So this is also part of the design research. When I speak about design research, this is about it. Another project is like based on that, I said, okay, I mean, those cubes are fine, but ultimately, if you assemble thousands and thousands of cubes, I mean, because of the tolerance, you might end up with something which is not exactly as stiff as what you want. So maybe a way to add additional stiffness is to pour in those cubes, some fiber reinforced concrete, So again, it was about trying to create a continuous mesh of concrete within this continuous network of cubes, and by the way, the very idea when I worked on this U-cube stuff was to have those cubes made of insulating material, so that the concrete and the structural component are never in contact, neither with the inside nor with the outside. So you don't have this kind of thermal bridges you can have in construction. Then you solve this issue of thermal bridge once and forever, So we started experimenting with casting fiber reinforced concrete in some cubes like this, or sand molds, 3D printed sand molds. But it was so complex that I said, okay, let's forget about that for the moment. We again, too expensive, too complex. So we kept the idea of this network of concrete, but we finally applied it in a more continuous manner, like this, trying to see what is the potential of complex networks, of complex three-dimensional lattices, especially if they are recursive lattices. So this is a project of 2002. And just to give you a bit of an architectural insight, I think it's also very, very in line with my interest in lightweight architecture. I'm interested in lightweight architecture, but not so much in lightweight structures like tensile structure or membrane structure. I'm interested in lightweight architecture mostly in its deep recursive nature. I mean, basically the difference between this kind of old style stone-based architecture, which can't be recursive, and this kind of steel-based architecture, which is deeply recursive. In fact, what I like in this is that this is full of voids, this is full of matter, and this is full of voids, and it's very much in tune and or in line with what I was interested in, and what I'm still interested in, by the way, in the discipline of architecture. If you look at that, there's a full history of lightweight structure which are conceptually amazing and also especially amazing as well. And obviously, thanks to 3D printing, we can also go much further than what we did in the past, you know. So these are things. And if you look at this, for example, this is based on genetic algorithm optimization. But if you look at that, you might have the feeling that it's maybe made of concrete, you know, but it's not the case. In fact, it's a skin which covers an internal steel structure, you know, in pretty much in the same way as Zaadid buildings are made. You know, but I love so much those things just before they are covered, you know. I like this very much, so I really wanted to go further and to experiment what could be done, not with steel, because obviously when it's in steel you can't really keep it uncovered, but in concrete, you know. So we worked on that, and eventually I had to ask myself new questions about the consumption of materials in the world, about the full potential of construct new design methods. For example, this is a project done by Japanese architects in Tokyo. But the problem is that here you see very advanced design methods, but when it comes to construction, it's still a very classical and traditional way of building this. So I wanted to contribute in that by focusing more on the three-dimensional lightweight lattices. So we first used 3D printing sand, you know, with a German company Voxel Jet. So this is in 2012. So it's 8 years old already. We had a small partnership with Lafarge, who provided us with concrete, with cement, you know, and we developed this kind of let's say of cast, you know, of molds with complex geometry made of 3D printed sand. And I said, okay, let's pour in some cement into that. So when you remove it, you know, you have this lightweight concrete structure, extremely lightweight. Just to give you an idea, in this structure, which is 1 meter 65 in diagonal, or even 1 meter 80. So the diagonal, the length of the diagonal. We used only 34 liters of cement, you know, 44 liters. So it's really nothing. It's really a lightweight three-dimensional lattice in concrete made of three-dimensional 3D printed sand molds. But again, you know, the issue here was about scaling it up. You know, again, it's a small prototype. How can we make it full scale? So I said maybe the only way to make it full scale is that rather than 3D printing in sand, maybe we should 3D print in concrete. Here are the mathematical experiments also behind that, etc., etc. And based on that, we created, with a few students of mine, we created a 3D printing company. This company was directly based on the work of Easy City that you can see here. This piece, for example, it's a moment where it was still experiments fully done and financed by Easy City before the creation of the 3D printing company s03. And so we said, okay, first let's try to see if we can 3D print the molds with a material which is a bit less expensive than sand, you know, and also with a faster method. So we did it with clay and then with concrete. But before showing this in more detail, just very quickly, recently I worked on a set design, on a graphic design project again, dedicated to the issue of artificial intelligence in art and architecture. Here it's an artificial intelligence which is capable of painting in such an amazing way as good as Rembrandt. And again, then you have to ask yourself, okay, what about architecture? Let me be clear. When we speak about architecture with capital A, you know, when we speak about Le Corbusier, when we speak about Mies van der Rohe or Rem Koolhaas, we speak about people who are inventing, you know. It's like speaking about Rembrandt, you know. I mean, when we speak about Rembrandt as a painter, obviously a machine cannot become Rembrandt, because a machine is not inventing the Rembrandt style that was invented by Rembrandt. But if we speak about a machine that can replicate the style and the perfection of Rembrandt, then machines can do it. So my thesis in architecture is the following. Maybe there's some room for 5 or 10 or 20 genius architects per century who can invent architecture. But when we speak about the architecture which is built every day in the world, we are not speaking about genius, you know. We are speaking about things that are in fact made in the style of somebody else. I mean, let's be honest. If we look at what is built nowadays, like 50% of all public buildings that are built today in the world are in the style of Rem Koolhaas. What I'm saying is that you can replace this 50% of buildings built in the style of Rem Koolhaas by an artificial intelligence that can design in the style of Rem Koolhaas. And artificial intelligence can do Rembrandt in the style of Rembrandt much better than most painter will ever be capable of in their lifetime. I mean, it's just a statement aside, but keep this in mind. So basically, I did this graphic design stuff with artificial intelligence using databases provided by curators, etc. It was very fun to do. I did it in Mathematica, doing analysis, pattern matching, things like that. You know, really nice. I mean, it was really fun to do. And yeah, but now the last part, I think I just need like 10 more minutes, probably less. The last part is about entrepreneurship. Again, when I worked on these three-dimensional lattices, you know, I was almost forced, for the sake of scaling, for the sake of architectural application, to create my own tools and company. You know, it's, you know, at that moment in 2014 and early 2015, there were no 3D printing companies being capable of 3D printing the kind of complex stuff I was interested in. So we say, okay, again, let's do it. And this was the let's say the prehistory of the s03 company, at the moment when it was still Easy City, financing stuff, initiating and doing the research, etc., etc. And so we printed in clay with different level of complexity, and this is a clay mold where we poured in cement so that eventually we obtain this fiber reinforced prototype of a structural column. Working on that, we made a prototype for the Swiss, for a small element for the Swiss pavilion by Christian Carretz at the Venice Biennale, but finally he didn't keep this method. He went up with a more traditional milling, CNC milling method, making use of foam. But this is what we proposed. Fully removable and reusable clay formworks like this. So this is the company. These are elements. Then thankfully, we got the support of some important software companies in France, basically Dassault Systèmes. We built also a small pavilion for them, like this. It was this pavilion that was installed in the suburb of Paris. So it was the launching of this pavilion. Also in 2012, we designed this project with an architect from south of France, Marc Dalibard. Obviously, at the moment, at that time, the funny thing is that we were mastering the pouring of concrete in clay mold. Sorry, not in clay, in 3D printed sand molds. You know, the black stuff I presented before. So we gave this as an answer to a public call. You know, we won the competition. I mean, it was not a big competition, but we won it. And we said, okay, let's probably we will build this by 3D printing sand molds and by pouring in concrete, fiber reinforced concrete in it. But between 2012 and 2015, the project, because it's a public project and those kind of projects are so amazingly slow, you know, that in the meantime, we developed a fully functional company and methods for 3D printing concrete. So finally, we said, okay, let's do it in concrete. Let's also make it maybe a bit more simple, because this was perfectly doable with sand, but it was not so easy to do with concrete. But still, we printed this in concrete. We simplified the whole structure. Here you see Marc, our partner from south of France, on the construction site. Here are some pictures I took myself on the construction site. So this was all 3D printed in concrete, and then it was finished with some sort of let's say, it's not a polishing, it's additional concrete finishing. Sorry, I don't find my word in English for that. And then again, we kept working on that, saying, okay, maybe let's try to do some more massive nodes like this, and that's it. This is a sample of what I've been doing in the last 20 years. Obviously, I didn't put the work done with my students, but what I can show you very quickly, it's a small video, and then you will also have an idea of the kind of work we are doing. I was doing, for example, last year with my student. We have done a lot also with matter, etc., etc. But let me show you a very recent example of, for example, in urban design, how we use applications to do to do urban design. So let me open that. Yeah. Okay, let me do that. Let me just unshare and reshare because I need to share the sound. And if I'm right, the only way to do that is to unshare and reshare stuff. So I'll unshare and yes. Okay, now you should get the sound of the video. So it's a 4-minute video. Is it okay, Alessio?
It's perfect, don't worry.
Okay.
Housing Prime. The world seems to be an application ecosystem. Here we ship our apps, then they ship us. The customers mainly participate in concept, design, material, and after-sales service. We believe in the near future, each building will have a digital twin. So we propose to build an app of which digital outputs will become cities. The house is hardly accessible and highly expensive. Inspired by WeWork strategies and the limitation of current apps, we try to get customized houses through agent-based design. Design, construction, and using stage have a digital twin respectively. We developed the app stack and built the linkage among each roles. Both a new app-based architecture. Created a technical workflow for a new architectural concept. To design the housing, we collect data, filter the site, generate the house. Followed a bottom-up logic from house unit to cluster and to community. Map the lands for sale. Set the 400 meters of respectively as an evaluation area. Locate facilities. Notify them around each land to filter more convenient ones. And classify their superiority to get the potential site. Based on household type, we define the basic needs and classify the room size. Collect more information to get almost every input. City rules generate the unit based on the linkage between rooms. And regenerate based on customers' feedback to get the final layout.
Basically, we have two types of cluster. One is public cluster, another is living cluster. In the living cluster, we provide users a variety of functions to choose and classify them into different groups based on their choices. This is an algorithm to locate housing units based on their personality and preference. For example, residents who enjoy socializing will stay closer to the public space. After that, we got a global structure of living cluster, and here are the circulation routes inside the cluster. Then we optimize the public space and housing units based on the circulation routes. Customers are able to discover lots of interesting activities in the cluster. It's just like a small ecosystem in the community. Through the app, customers are able to see their relationship with neighbors and public spaces. Here is the overall effect of living cluster. And here are some details.
Besides living clusters, we create some types of public clusters. We design another algorithm. Each time we improve the shape of floor, it will generate circulation and then create different size rooms. Getting the data of layout, the algorithm will automatically generate all details from stairs to furniture. By this way, we create sports center, work office, and shopping mall. Through the combination of different clusters, we put various event sequences into the community, creating an urban complex full of stories. We use the idea of activity sequence to organize the structure of clusters. Then we use physical engine to simulate their connections. By this way, we can get the position of each cluster. Each point will occupy a number of closed boxes. We use genetic algorithm to optimize the result. The following steps will be totally automatic based on the algorithm we studied before. Here's the final effect. Here are some details. We have also considered how to make a connection between several communities. We build bridges to link different green space. Then we materialize the past data based on the way we used before. After generation, the geometry data will be sent to the application to tell the customer of how his home look like. In conclusion, we develop a workflow of architectural automation as the application backend to support the platform in which the customer can join in the process of designing. We believe in this new mobile area, this bottom-up design strategy will be more realistic in market than ever. Thanks.
Don't you want to create your dream house by matching you to fit your lifestyle, wish list, and needs? Well, now there is a better way. Housing Prime changes how you get a new house all through your mobile device. Log into the mobile app. Choose your city and select a hobby. Then pick up your ideal location. You can choose how long you want to stay here. Are you single or couple, or a family with children? Which function do you need? Do you prefer to have a private kitchen or shared kitchen? Now our customer algorithm is working for you to select your houses. You will get several house types as options, such as different layout. You could also have a closer look of your favorite one and check out its design features. You can even change the layout in real time. For example, moving the wall with flexibility according to your needs. For more information, check our website. You will have more comprehensive understanding of your community, such as the urban surroundings, the transport, living facilities. Share what's going on in the building and community. Encourage your friends to move in and make your community great. Real feedback, real facts, and real visualization. Housing Prime delivers what you need when you need it.
Okay, thanks a lot.
Thank you very much, Philippe.
So thanks a lot. Obviously, this last video is about what I believe to be an important aspect of architecture, which is not only what we do, what we design, or even the way we produce it, but also how we bring architecture to the people. And I also believe that at some point it's an important parameter and probably something that architects should think about. You know, if architects don't do it, Google, Amazon, and Airbnb will do it for us. You know, so at some point, either we want to be driven by Airbnb, or maybe architects can invent the new Airbnb-like, let's say, way of bringing architecture to the people. So yeah, that's an open debate.
Yeah.
I see a question about having the video. Yeah, I think it's available online. I will send you the link, Alessio, and you will be able to send it to share it with your student.
Sure, definitely. I would like to open up the floor for questions from the students. But before taking the questions, I would like to make a consideration about your last point, Philippe. I mean, it's really important and relevant because we need to get as designers, as architects, to be able to navigate these modes of interaction and distribution, but without the corporate mentality that is behind what you quoted, like Facebook, Google, MBB. This is goes right into the arguments made by Sir Isaac Williams, like in platform capitalism, for instance, or reasoning. Like, I think it's more and more interesting how in the last, I think 2 or 3 years, it's a very recent thing, we have rediscovered the inevitable interconnection and with them also the limits of agency that we have between architecture, politics, and economics. And I think it's really important that we try to understand what might be the relevance and the role of an architect in this new scenario. Yes. I think you made some very important points all through the presentation about that.
I believe again that the influence of the computer, is so deep that we need to readdress almost all aspects of the discipline of architecture. That's a problem. And by the way, that's also why it's so difficult to build a discourse or theory, because you have so many things that we need to take into consideration. For example, again, like we can say, oh, it's great with non-standard, with new kind of tools, we can produce non-standard architecture, for example. Right, but at the very moment, if you look in an objective manner, what people can do, they have absolutely no impact on what is built, at the very moment. So maybe architects can do non-standard architecture, but the client has no effect on that. But the real social interest, for example, of non-standard architecture, it's not to please the architect. It is to allow clients, to allow people to have a different kind of relationship with their dwelling, with the architecture they pay for. That's the problem. Architecture is probably one of the very few things you pay for it without having the opportunity to choose it. That when you think of it, it's kind of insane. If you look at the developers, if you look at what is built, especially in European cities, you have this kind of extremely stupid apartment buildings. People have no choice. I mean, there's also a shortage in dwellings. So more or less, when you find one which is not too expensive, yeah, you're happy with it, So, but obviously, if you want to buy a computer, if you want to buy a smartphone, you have much more choices. And also, when you pay for a smartphone, you pay for the best technology that ever existed in the world. When you pay for an house, you definitely don't pay for the best technology that is available today. So there is I think architecture at the very moment is in deep trouble because now it's becoming more and more obvious that the discipline is in crisis, that it's driven by developers who are absolute crooks for most of them. They deliver shit and they sell it the price of gold, and it's becoming obvious because again you can buy state-of-the-art technology when you buy a smartphone, and you have access to the entirety of the knowledge that was ever produced by the world, because you have an access to internet, to Wikipedia, and to all of that. So the discrepancy between the very primitive state of architecture and the absolutely amazingly advanced stage of information technology is becoming more obvious than ever. So yeah. we should learn from that, I think. Maybe without losing our interest in the materiality of architecture, in maybe the rationality of its construction, maybe the beauty of space. I'm okay with these things, if you go to a restaurant, it's also a matter of taste, What I'm saying is that again, what you know, at the very moment, architecture is produced with old-style method by old-style people who copy each other. That's mostly what architecture is about. I just propose to replace this by machines, obviously, but not only for the construction, but also for the design. You know, I believe that machines are smarter than us, and architects should probably remove themselves consciously from the game. It might be a provocative statement, but are doctors, you know, do doctors practice the art of medicines for the benefit of people or for their own benefit? You know, I mean, it is for the benefit of people. I mean, it's a Hippocrates thing. I don't know how to say this in English.
Hippocrates oath.
Yeah. So what about architecture? I have the feeling that most architects practice architecture for them, not for the people, and not for the benefit of architecture as a discipline. If we do that, if we really do practice architecture in the benefit of the architecture itself, then we have to say, well, it's time for us to take a step back and to remove ourselves from the game, because there are new kinds of architects who are smarter than us, and these new kinds of architects who are smarter than us are artificial intelligence and machines.
Excellent. We had Neil Leach as a guest last week.
Yeah.
So he's making a very similar argument for the role of the architect. Actually, he was even more dramatic in saying the death of the architect.
Yes.
Yeah, I know where you and Neil are going with the argument. I can say that I personally agree with that, with the statement. We'll have to definitely rethink radically, and I think presumably also quite quickly, even for instance our role as educators. So
yes.
What we teach, why we teach it, how do we fill the gap between what comes previously in the educational system and what will be the nature of the new working environment and working scenario. It's going to be a huge argument, I think, in the next years.
I think so too.
So let's see if we have some questions from the students.
They are too shy.
But usually they take some time, but some questions usually. Usually. I hope they, because otherwise I have like a long list, but I didn't want to monopolize the conversation. I'd rather prefer them to speak their mind.
Maybe they should turn on the microphone and camera.
Yeah, we can try that. Come on, guys, switch. Show us your face. Show us that you're not just avatars. Of course, if you want to. But...
Hello, thanks for the presentation. I am Lorenzo, and I have a question, because I was very surprised from the last part of the presentation, and also from the work of the students. By the capacity, technology open to design entire urban landscapes but also by the inevitable uniformation of spaces which derives from operating in this large scale. Don't you think that to preserve diversity and also individuality, it could be more applicable to reduce the scale of architecture more closely to human scale, and let so the city grows like an assembly of little architectures and not like a pattern of giant independent structures? So this is my adapt, which derives from observation of work that generally I think it's very interesting and well made. So it's not a critic; it's like only an observation.
Yeah, I have to say that personally, I consider myself a very, let's say, anti-urban guy. By anti-urban, I mean like, yeah, I even taught classes in Paris for many years, whose title of the theory class and seminars was towards an towards an anti-urbanism, you know. So yeah, I prefer also smaller scale things, especially when it comes to dwelling, rather than this kind of big, very big buildings with accumulations of flats and apartments. I'm really a defender of the house.
Yeah.
So yeah, I can understand what you mean. I more or less share that too. But again, it's a student project, and it's not when we work with a student, it's not about my own taste. You know, it's more about making sure that they develop a kind of sound approach, a kind of integrative approach, which again, both conceptually and technically speaking, make sense.
Yeah. Okay. Thank you.
Yeah, it's what you said right now, Philippe. It's also important to me to transmit, which is when you teach, it's more important to transmit a way of constructing a sound methodology to develop a curiosity in a systematic way to root and flourish what you are searching, and not just stay on the surface of things, rather than what is the thing in itself. Of course, the thing in itself has its relevance at up to some point, but the attitude becomes primary.
Yes.
Any further questions from the audience? Because if there is anything, I mean, there are a few considerations that I would like to bring to the table, since we have our last, let's say, 10 minutes to talk about. I introduced the course with the students, making a parallel with the scenario that was in front of architects and society around the 60s. There was a huge radical technological innovation, which was mechanization and industrialization, which was about to enter and completely change the face of architecture, of a certain kind of architecture. And arguably, one could say that the most relevant architect turned out to be Neufert from that age, which didn't build very much, but in the end reshaped completely, thanks to the Plattenbau system, to a lot of technological innovation. And we are in a similar situation, which means we are, what I mean by that is we are on the brink of a huge ingress of artificial intelligence and automation in lecture. And what does that mean for how can we imagine the way in which the face of architecture could change due to that? Of course, there will be still architects that will still do their own way, their own things in a traditional way, more or less traditional way. But then what resulted from that year of certain architects, the common sense about architecture, about the place we live, the place let's say the 90% of the built environment was much more influenced by those who, or in a way, they were subjected to industrialization and then passively flooded the environment with things that were optimized just for the crane capacity rather than around the human. I mean, they intended it to be around the human, but then they passively applied the principle of minimal resource optimization up to the point that the objective was certain kind of economy, not a more comprehensive, to avoid repeat. And also the most important part was this compression of scale, in which from a construction system you get to an urban scale very, very quickly.
Yes.
The object of our study this year is something that interacts and intercepts between just a very simple system of modules up to the urban condition. Because in the end, even if you want to act small, that can have huge consequences and ripples. So yeah, that is sort of a premise for this course. And I think that this changes everything. The thing that the passage from rationalism to computationalism is one of the most, I mean, it's more relevant than ever. The sentence, this changes everything. It was repeated many times in the past, but I think this is really the moment in which it might be absolutely founded and true.
Yes, I think there's probably absolutely nothing at the very moment on which a computer does not have some effect. I think nothing exists without the computer. Maybe the way the people let's say, produce bread or things like very basic things like that. Maybe we don't need a computer to manufacture bread, but even this is wrong because if you look at the way the raw ingredients are produced in factories, even for that, they make use of computers. So I think computers are just absolutely everywhere around us. But when it comes to architecture, there's something specific because architecture is dealing with materiality, and everything which has to deal with matter and physicality, it's quite slow. Architecture is about hardware ultimately, and what's moving fast in our present-day society is mainly driven by software. So the question is, if we consider architecture as a kind of hardware, what kind of hardware should it be? Should it be an hardware that can evolve, that can be updated, or something that should be disposable? For example, as you said, you mentioned the 60s, but in the 60s there was also this kind of dream of an house that you built for a few years, and then you destroy it, and then you recycle it and you rebuild a new one, etc., etc. So all of these questions are not really answered. I don't know if we can really solve this. It's a very tricky tricky question. When you look at an house, for example, most of the components within the house itself are renewed. Like every few years, for example, you change your TV, your refrigerator, your sofa, your washing machine. You know, all of this equipment in the house are upgraded, you know, every few years. You know, they are replaced every few years. So if we look at the architecture, it's probably, I mean, again, I don't have real answer for that about what is the best strategy when it comes to the construction of the architecture. Maybe the best is simply to build some very basic structure in concrete, some sort of domino house dwellings, so that they are as neutral as possible and people can do as much as they want within this, I mean, between those two layers of concrete, you know, the floor and the ceiling. And by the way, this is also why I'm absolutely fascinated by the domino house. I call it the Turing machine of architecture, you know, because that's the most universal construction system that has been produced in the 20th century. You know, also the cheapest one. You can do any kind of building based on the domino principle. You can have as many stories as you want. You know, you can do an house, you can do a skyscraper, you can do more anything, you know. So I believe that let's say the way we deal with materiality and the way we deal with the issue of evolution in architecture is still a very problematic and unsolved. We know how we can deal with evolution when it comes to your car, when it comes to the computer, when it comes to the smartphone. We know how long a smartphone is going to last. You know, for example, you know that if you are careful, maybe it's gonna last 3 years as a state-of-the-art technology that will be fast, etc. But after that, you will start to consider it far too slow compared to the latest version. You will also consider maybe that the camera, the embedded camera doesn't have a resolution which is good enough, or etc. etc. You see, so we know the life cycle of things. We know that it's gonna stay, that for 3 years it's gonna be a good smartphone. Then between 3 and 6 years it's gonna be a bit old, you know, and probably after 6 years it will start dysfunctioning, probably because of the fragility of the hardware, you know, things like that. And maybe even if you are extremely careful, maybe then you won't have the software update, you know, so that you will have no other choice than throwing it away in a trash can, you know, more or less that's. But when it comes to architecture, those things are not clear. We have everything. It's completely chaotic. You know, some architecture lasts for 10 years in really good shapes, some other for 50 years, some other after 3 years, it's all in very bad condition because it was extremely poorly built. We don't really know even if Neufert is, I totally agree with you, was extremely influential because of its standardization project. We don't know how long such or such an element in a building is going to last. You know, it's in fact, we live in a world in which evolution is probably the most important word. And architecture doesn't know how to deal with evolution.
Yeah, that's extremely problematic, actually.
Only in terms of design, you know, maybe. When it comes to design, it's easier. I mean, for me, it's quite clear. I mean, design just need to follow the pace of software evolution and updates and all that. As simple as that. I mean, architects should use the latest capacities offered by artificial intelligence tools, for example. There's no reason that Facebook is using the state-of-the-art in artificial intelligence and architects are using methods that are in best case scenario when you use AutoCAD 30 years old, you know. So when it comes to software, it's also easier to take a clear position. My own position is extremely clear, you know. It's like state-of-the-art artificial intelligence technologies. No discussion. That's my position. But when it comes to construction and to hardware, it's much more difficult.
Yeah, that comes back with the thing about filling the gaps that I was quoting before. That is I think that's a huge part of the problem to work on the interfaces between the state-of-the-art design methodologies, the construction systems, the education users. I mean, there are a lot of rifts because things move at very different speeds in
Yes.
in different disciplines and in different parts. But, well, it's also a start to recognize where the problems are. I think it's quite a good start, actually. Well, I think we are a bit over time, but it was interesting. I don't know if there are any questions, like any last questions from the audience, or I don't know if you have to go, Philippe. I mean, we can also.
If there is a last question, it's okay.
Anybody? Okay. Well, apparently today they are a bit shyer than usual. But I hope they found your contribution as interesting as I did. So again, thank you very much, Philippe, for being today with us. And I hope if you want that I can exchange the favor one day, or that we will be able to meet soon again in Paris, probably.
Yeah, I hope so.
Okay. Again, thank you very much, and best of luck for everything from now on. In this period, I think we all need it.
Yeah, thanks a lot. You are in Milano, but your students are in Bologna. Or you are also in Bologna right now?
Yes, I am in Bologna.
Okay.
Yeah.
Okay, great.
Thank you very much, and
okay, thanks a lot.
Goodbye, everyone, and we'll send you the links and the notes in the chat and through Teams.
Okay, perfect.
Have a nice day. Bye, everyone.